Welcome to the Math School by IFRA. In this video, we are going to discuss permutations and factorials. Suppose you want to determine the number of different ways the three letters A, B, and C can be placed in order from first to third. The following is a list of all the possible orders in which the letters can be placed: ABC, ACB, BAC, BCA, CAB, CBA. There are 6 possible orders for the three letters. Now suppose you want to determine the number of different ways the 4 letters A, B, C and D can be placed in the order from first to fourth. Listing all of the orders for the 4 letters is time consuming, so it would be useful to be able to count the possible orders without listing them. To order the 4 letters, one of the 4 letters must be placed first. One of the remaining 3 letters must be placed second, one of the remaining 2 letters must be placed third, and the last remaining letter must be placed fourth. Therefore, applying the multiplication principle, there are 4, 3, 2, 1 or 24 ways to order the 4 letters. More generally, suppose n objects are to be ordered from first to nth, and we want to count the number of ways the objects can be ordered. There are n choices for the first object, n minus 1 choice for the second object, n minus 2 choice for the third object, and so on, until there is only one choice for the nth object. Therefore, applying the multiplication principle, the number of ways to order the n objects is equal to the product n minus 1, n minus 2, dot dot 3, 2, 1. Each order is called a permutation, and the product above is called the number of permutation of n objects. Because products of the form n minus 1, n minus 2, dot dot 3, 2, 1 occur frequently when counting objects, a special number n factorial called n factorial is used to denote this product. For example, 0 factorial is 1, 2 factorial is 2 times 1, 3 factorial is 3 into 2 into 1, 4 factorial is 4 into 3 into 2 into 1. As a special definition, 0 factorial is 1. Note that n factorial is n minus 1 factorial is equal to n minus 1, n minus 2 factorial is equal to n minus 1, n minus 2 into n minus 3 factorial, and so on. Let's have a look at one example. Suppose that 10 students are going on a bus trip and each of the students will be assigned to one of the 10 available seats. Then the number of possible different sitting arrangements of the students on a bus is 10 factorial. 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 1 is equal to 3,628,800 is our answer. Let's have a look at another example. How many different 5-digit positive integers can be formed using the digits 1, 2, 3, 4, 5, 6 and 7 if none of the digits can occur more than once in the integer? This example asks how many different ways there are in order to order 5 integers chosen from a set of 7 integers. According to the counting principle above, there are 7, 6, 5, 4, 3, 2, 7, 6, 5, 4, 3, 25, 20 ways to do this. Note that this is equal to 7 factorial over 7 minus 5 factorial is equal to 7 into 6 into 5 into 4 into 3 into 2 factorial over 2 factorial. 2 factorials are cancelled out, so the answer is 7 into 6 into 5 into 4 into 3. Okay, let's have a look at combinations. Given the 5 letters A, B, C, D and E, suppose that you want to determine the number of ways in which you can select 3 of the 5 letters, but unlike before, you do not want to count different orders for the 3 letters. The following is the list of all the ways in which 3 of the 5 letters can be selected without regard to the order of the letters: ABC, ABD, ABE, ACD, ACE, ADE, BCD, BCE, BDE, CDE. There are 10 ways of selecting the 3 letters without order. There is a relationship between selecting with order and selecting without order. The number of ways to select 3 of the 5 letters without order, which is 10, multiplied by the number of ways to order the 3 letters, which is 3 factorial or 6, is equal to the number of ways to select the 3 of the 5 letters and order them, which is 5 factorial over 2 factorial, which is 60. In short, number of ways to select without order into number of ways to order is equal to number of ways to select with order. This relationship can also be written as follows: number of ways to select without order is equal to number of ways to select with order over number of ways to order. For the example above, the number of ways to select without order is 5 factorial over 2 factorial over 3 factorial. That is 5 factorial over 2 factorial into 3 factorial, that is 10. More generally, suppose that k objects will be chosen from a set of n objects where x is greater than 0, but that the k objects will not be put in order. The number of ways in which this can be done is called the number of combinations of n objects taken k at a time, and is given by the formula n factorial over k factorial into n minus k factorial. Okay, let's have a look at another example. Suppose you want to select a 3-person committee from a group of 9 students. How many ways are there to do this? Now, since the 3 students on the committee are not ordered, you can use the formula for the combination of 9 objects taken 3 at a time, or 9 choose 3. 9 factorial over 3 factorial into n minus 3 factorial is equal to 9 factorial over 3 factorial into 6 factorial. 9 into 8 into 7 into 6 factorial and 6 factorial are cancelled out, and 3 factorial is 3 to 1, and that is 84 is our answer.